The first thing we can look at is content loss. So we've got this network. We know we have these fully connected layers and a softmax at the end. We don't care about those fully connected layers and the softmax. Let's say we get rid of those. So we make a new model where we rip those out. That's not uncommon, right? That's what we normally do in any sort of a transfer learning problem, right? Where we'll take a pre-trained convolutional neural network. What we do is we strip out the old fully connected layers and often put on our new fully connected layers. In this case, we don't have a need to put on new fully connected layers. So what we can do is look at one of the last convolutional layers in this neural network. We know its output is something like this, right? So this is the output or activations or feature maps. Right, these are all equivalent for this layer. We know it's going to be smaller in height and width than the content input because we know our convolutions go smaller and smaller and smaller. Right? So we've got this size, we've got this 512 different features, and then telling us various pieces of information about this image. We don't know exactly what. It's whatever it happened to learn that would be useful in order to determine what this image is later on with these convolutional layers. Early in the network is fine-tuned type details like horizontal lines, vertical lines, diagonal lines, brightness, those sorts of things. And as we move through the neural network, we build up larger and larger sorts of features and also more abstract. So what we're trying to do is some abstraction. Let's even back up for a second. What about this as a loss? We take the content, we take the combination, and we just do a mean squared error between the two. Okay? The problem with that is if we consider the output that we're looking for, the combination we're looking for, that includes styles as well. If we've got a building here, we might want to have a building here, but we don't need it to be pixel for pixel of the building. In fact, that if it is pixel for pixel of the building, we're not taking into account the style at all. Okay. So if we've got, let's say, a building that looks like this, and we have a style that kind of makes things lean, maybe this would be a good stylistic version of the house. But pixel for pixel, it's completely different, right? Maybe this corner and this corner are the same, but then this one moves, this one's the same. So looking at it pixel by pixel just isn't going to work very well for this particular problem. Instead, we want to be looking at a higher level abstraction. So things like having a house in the right corner, or having a river type thing, or having some sky, stuff like that is what we're looking for. And so our idea is if we look late in our neural network, that will contain abstract information as opposed to sort of the pixel type information. And so that's why we're going to use this basically as a summary of our content. The theory is if you feed a picture in here, and then you pull out these activations at the last or one of the last convolutional layers, that it is a summary of what's going on in that picture. And what we can do is we can feed in our original content image and capture these activations. And then we can feed in our combination image and also get the activations. And those will what we'll do a mean squared error on. So we will basically compute the output activations for iContent. And then we'll do it again for iComb. And then what we can do is do a mean squared error difference between this activations and this set of activations. And our hope is that our neural network will not really care so much whether this is a building with straight up and down lines or slightly, bent lines, that it'll still recognize it as a building there, or at least recognize that we'll have the same sort of activations in both cases. So that is how we're going to do the combination. So what are we going to do? We're going to basically take some convolution layer here, right? So this is going to be the output of a convolution. So this is going to be some A at, I don't know, let's just say 30. Okay, it's the 30th layer in here. So that is this one. So this is for the I content. We'll also calculate A at 30 for the I comb. And we'll take a mean squared error on this whole thing and just sum it up, right? So we'll get a single number. So that will give us a loss for the content. Again, how different is the late convolution layer output for this image as compared to our original content image?